2 years have passed since NASA's James Webb Space Telescope provided us with a breathtaking first glimpse into the deepest parts of our universe. This $1 billion telescope stands as the largest and most powerful one in space. After taking stunning pictures, the James Webb Telescope revealed something that NASA had been concealing about Mercury. As a result of this discovery, the mission was quickly halted by the United States. This seemingly normal world is far from what it seemed. As it orbits close to our massive sun, Mercury's scorching landscape is dotted with surprising phenomena, including sparkling diamonds. But beneath its glittering surface lies a vast and mysterious element that challenges our past scientific knowledge. What other hidden truths lie behind these amazing revelations? Let's explore the discoveries that could significantly alter how we understand the planet. Although Mercury may seem small, don't let the comparison to the Sun fool you. Beneath its rapidly boiling surface lies a wealth of incredible secrets. Recently, probes from Earth discovered a shocking revelation: Mercury's surface is littered with diamonds. These remarkable gems exist on one of the hottest planets in our solar system. But as we dig deeper, this is just the beginning. We discover that Mercury's core is both strange and incredibly large. These findings raise crucial questions. What sets Mercury apart from its neighboring planets? What other hidden phenomena might it conceal? The spacecraft Mariner 10 was the first to reach Mercury, establishing it as a pioneer in space exploration. It returned the initial close-up photographs, revealing a planet with strange features, craters and ridges much like our Moon. This mission shattered preconceived notions about Mercury's makeup, showing a rough surface, a surprisingly powerful magnetic field, and a larger-than-expected core. But that wasn't the most shocking revelation. 3 decades later, the Messenger mission transformed our understanding of Mercury. Unlike Mariner 10, Messenger was designed to orbit Mercury, enabling detailed, long-term observations. It captured nearly 200,000 images, significantly expanding our knowledge of the planet and uncovering previously hidden regions. Among Messenger's key findings was the discovery of unusually high concentrations of calcium and magnesium. This sparked interest in Mercury's darker side and the natural processes responsible for these elevated levels. Scientists were also surprised to learn that, unlike other solar system planets, Mercury's magnetic field was remarkably stronger in its northern hemisphere. These findings forced scientists to reconsider their past assumptions about Mercury's interior and geological development. On Earth, the movement of molten iron within the core produces magnetic fields. However, Mercury exhibits a unique kind of magnetic activity due to its distinct internal structure. What else sets Mercury apart? The planet's craters and ridges experience extreme weather. During the day, temperatures can soar to a scorching 860 degrees Fahrenheit, hot enough to melt lead. At night, temperatures plummet to about -292 degrees Fahrenheit. Mercury's thin atmosphere does little to retain heat or regulate temperature, resulting in dramatic changes. But there's more. Mercury's extreme heat isn't the only astonishing characteristic. The Messenger mission in 2012 revealed historical evidence of explosive eruptions and signs of ongoing volcanic activity, challenging earlier theories that Mercury had been geologically inactive for billions of years. Then, in 2020, researchers made another fascinating discovery. Parts of Mercury's permanently shadowed polar craters contain water ice. Despite Mercury's proximity to the Sun, these regions remain cold enough to preserve frozen water, as they are shielded from direct sunlight. This discovery raised fresh questions. Could Mercury support prehistoric organisms in these frozen regions, much like Earth's most inhospitable environments? The implications for our understanding of life's potential to thrive in harsh environments are profound. But the story doesn't stop there. In 2018, in collaboration with the Japan Aerospace Exploration Agency, the European Space Agency launched the Bepicolombo spacecraft toward Mercury. It is expected to reach the planet by 2025. Once there, Bepicolombo will begin gathering extensive data about Mercury, including the composition of its surface and geological history. Interestingly, despite being so close to the Sun, Mercury has both water ice and a strong magnetic field. What might surprise you even more is that a day on Mercury is actually longer than its year. When we think of a planet, we typically imagine it orbiting the Sun once a year and rotating on its axis once per day. However, Mercury defies this expectation. A day on Mercury, meaning one full rotation on its axis, takes about 176 Earth days, while its orbit around the Sun takes only 88 Earth days. This means that a single day on Mercury lasts 2 of its years. As observed from Mercury, the Sun rises and gradually expands across the sky. Then, something strange happens. The Sun appears to halt, retrace its steps, and then continue on its journey. This is due to Mercury's slow rotation compared to its quick orbit around the Sun. Why does Mercury rotate so slowly? The answer lies in tidal locking. Over billions of years, the Sun's gravitational pull has gradually slowed Mercury's rotation. Mercury is in a 3:2 spin-orbit resonance, meaning it completes 3 rotations on its axis for every 2 orbits around the Sun. This results in a unique day-night cycle and contributes to Mercury's extreme temperature variations. The Sun-facing side reaches scorching highs, while the opposite side remains in extensive icy darkness. These temperature swings are among the most extreme in our solar system. It's important to note that Mercury doesn't have a traditional atmosphere like Earth. Instead, it has an extremely sparse and thin exosphere that continuously evaporates into space. This exosphere is occasionally replenished by solar radiation and collisions with small space debris. Recent research has revealed unexpected details about Mercury's exosphere. In 2020, data from the Messenger spacecraft demonstrated that scientists had previously underestimated the volume of water vapor in Mercury's exosphere. This vapor likely forms when oxygen from Mercury's rocks interacts with hydrogen from the solar wind. Another astonishing feature of Mercury is the speed at which it orbits the Sun, especially in comparison to its slow axial rotation. This strange combination significantly impacts the planet's magnetic properties. Scientists were astounded to discover that Mercury has a strong magnetic field despite its relatively small size and slow rotation. Further studies indicated that Mercury's unique spin and orbit, along with special movements within its core of liquid metal, contribute to its magnetic field. It's important to remember, though, that while Mercury has a strong magnetic field for its size, it is still weaker than Earth's. Nevertheless, it helps protect the planet's surface from the harsh solar wind. Without it, Mercury's already sparse exosphere would be even thinner. Mercury's slow spin and rapid orbit create extraordinary conditions. For instance, the planet has regions known as hot spots where the Sun appears to hover in the sky for extended periods, causing extreme heat. Meanwhile, areas near Mercury's poles remain in constant darkness, cold enough for ice to survive, despite the planets. These new revelations about Mercury's formation challenge long-standing theories about how inner planets evolve in our solar system. Mercury, with its oversized core, thin silicate mantle, and peculiar orbital behavior, appears to be a planetary enigma, one that doesn't neatly fit into our existing models. Some scientists speculate that Mercury may have once been a much larger planet, possibly similar in size to Earth. Over billions of years, catastrophic collisions with other celestial bodies may have stripped away its outer layers, leaving behind a dense metallic core that dominates its interior. This theory, known as the giant impact hypothesis, could explain the planet's strange density and magnetic properties. If true, this violent history adds a dramatic chapter to Mercury's story, a world once whole, now reduced to a scarred and molten shell, holding on to secrets buried deep beneath its surface. Meanwhile, the continuing study of Mercury is pushing the boundaries of planetary science. Every new discovery, whether it's the presence of water ice in shadowed craters, volcanic remnants, or magnetic anomalies, forces scientists to ask deeper questions. How did Mercury come to be this way? What can it teach us about the formation of other rocky worlds? And, ultimately, what does it tell us about Earth? The answers might not only reshape how we view the smallest planet in our solar system, but also provide valuable insight into the conditions that make a planet habitable, or not. As Bepi prepares for its orbital insertion in 2025, excitement in the scientific community continues to build. With its advanced sensors, spectrometers, and magnetic field analyzers, the spacecraft is expected to deliver unprecedented details about Mercury's composition, surface chemistry, and geologic evolution. There's hope that this mission may even uncover new elements or compounds hidden beneath the surface, waiting to be studied and understood. The data could lead to breakthroughs in our understanding of planetary magnetism, internal heat retention, and crust formation, knowledge that may be applied not only to Mercury, but to exoplanets in distant solar systems. What started as a simple curiosity about a planet close to the Sun has now evolved into a quest that touches on the very fabric of planetary science, astrophysics, and the origins of life. Mercury, small, battered, and blazing under the solar spotlight, is no longer just a barren rock. It is a dynamic, complex world that has survived unimaginable forces and now stands as a key to unlocking the ancient history of our solar system. And with every mission, every image, and every byte of data sent back across the void, we come one step closer to answering some of the biggest questions in science. Where did we come from? What shaped the worlds around us? And could the conditions for life exist even in the most unlikely of places? Planetary evolution. As scientists continue to explore, new questions arise about Mercury's unique core, surface, and the factors that have shaped it over time. The more we learn, the more we realize how much Mercury impedes our comprehension of planetology. Mercury is currently still the smallest planet in our solar system, and it holds many secrets that continue to fascinate scientists. One of the best ways to enthrall scientists is by studying Mercury's remarkable characteristics. One such characteristic is its gigantic core. According to planetary scientist Dr. Nancy Cabot, Mercury's core represents approximately 85% of the planet's total volume, while Earth's core accounts for just 15% of its total mass. This raises a crucial inquiry: why does Mercury have such a vast core? One widespread theory suggests that Mercury was once much larger but lost much of its outer layers because of a huge collision early in the history of the solar system. This theory, known as the hypothesis of a massive impact, suggests that a massive object collided with Mercury, stripping away its outer layers and leaving behind the dense, iron-rich core we currently observe. Mercury's magnetic field, though weak, is also a fascinating source of study. Despite the planet's small size and slow rotation, scientists were surprised to find that Mercury, unlike Venus and Mars, has a global magnetic field. This discovery, made by NASA's Messenger spacecraft, led to further studies. Researchers also discovered that the magnetic field of Mercury is uneven. Dr. Katherine Johnson and her team found that Mercury's radius is displaced by about 20%, which may be related to changes in the planet's crust and the way heat is released from its core. In 2020, further studies revealed that volatile substances, such as sodium, potassium, and sulfur, are present on Mercury's surface. These findings contributed to the expanding body of knowledge about Mercury, making it one of the most exciting planets in our solar system to study. As we continue to explore, Mercury's mysteries are still unfolding, challenging our understanding of planetary formation and evolution. The mysteries surrounding Mercury continue to captivate scientists. As researchers dive into its numerous enigmas, some discoveries offer glimpses into its complex nature, though many unknowns still remain. One of the most intriguing aspects of Mercury is the presence of compounds that would typically vaporize at such high temperatures. Dr. Patrick Peplowski from the Johns Hopkins Applied Physics Laboratory has put forward the theory that comets or asteroids might have delivered these materials much later in Mercury's history. One of the most exciting revelations about Mercury is the existence of water ice in the shadowed craters that remain at the planet's poles. This discovery was made possible by the efforts of Dr. Nancy Cabot. These craters are so cold that the ice remains frosted. The potential presence of complex carbon molecules, similar to those that may have sparked life on Earth, adds another layer of intrigue. Could Mercury, with its extreme conditions, offer clues to the origins of life in our solar system? When it comes to Mercury's geology, there have been more surprises than previously thought. Though believed to be geologically inactive for billions of years, new data from NASA's Messenger spacecraft shows recent volcanic activity. Dr. David Ree from the Open University in the UK uncovered tiny hollows, bright volcanic vents, which provide insight into the planet's ongoing geological processes. These surface features suggest that Mercury's geology may still be evolving. Another peculiar aspect of Mercury is its chaotic terrain, a vast, disordered region near the southern pole first identified during the 1970s Mariner 10 mission. Dr. Thomas Waters of the Smithsonian Institution proposes that large, Earth-like earthquakes caused by the gravitational pull of the Sun may have shaped this landscape. Mercury's internal structure is just as fascinating. Using information from Dr. Amir Kh, a researcher at the University of Zurich, scientists revealed that Mercury has a large solid inner core surrounded by a liquid outer core, much like Earth. However, Mercury's inner core is much larger, which could explain its unique magnetic characteristics. This unexpected information challenges our understanding of planetary formation and evolution, demonstrating that many secrets still lie within our solar system. The Messenger mission also discovered that Mercury's mantle is thin, only 260 to 420 kilometers thick, in comparison to Earth's much thicker mantle. This thin mantle influences the planet's heat distribution and geological activity. Researchers found evidence of ancient volcanic activity beneath Mercury's surface, including shallow depressions called hollows that formed when volatile compounds near the surface evaporated. In 2020, scientists found signs of a large magma reservoir that once lay beneath Mercury's surface, shaping large flat plains, particularly in the northern hemisphere. These volcanic plains, known as the northern volcanic plains, were likely formed by massive lava flows early in Mercury's history. Further analysis of messenger data in 2022 revealed additional mysteries and hints of nitrogen trapped beneath the surface. This suggests that Mercury might have once had a denser atmosphere that was later sucked down below by the planet's extreme heat and unending solar radiation. Another fascinating discovery involves the ice found in the permanently shadowed craters at Mercury's poles. Despite the Sun's proximity, these craters remain frozen, protecting the ice from melting. This paradox continues to puzzle scientists and adds yet another piece to the ever-growing puzzle of Mercury. These discoveries not only deepen our understanding of Mercury but also prompt broader questions about the evolution of rocky planets. If Mercury, despite its proximity to the Sun and its relatively small size, retains water, ice and volatile compounds, could similar surprises be hidden within other planetary bodies? Mercury challenges assumptions about where and how certain materials can exist, pushing scientists to re-evaluate long-held theories. Another area of intense interest is Mercury's exosphere, an extremely thin atmosphere composed of atoms blasted off the surface by solar radiation and micrometeorite impacts. This exosphere contains elements such as hydrogen, helium, oxygen, sodium, calcium, and potassium. Unlike Earth's dense atmosphere, Mercury's exosphere is so thin that it doesn't behave like a traditional atmosphere but still offers clues about surface composition and solar interactions. The presence of sodium and potassium in particular has been intriguing. These elements are often associated with youthful geological activity or external delivery from space. Their distribution across the surface has revealed a pattern that suggests complex and perhaps ongoing interactions between Mercury's surface and its space environment. Scientists are also intrigued by Mercury's orbital and rotational dynamics. It has a 3:2 spin-orbit resonance, meaning it rotates 3 times on its axis for every 2 revolutions around the Sun. This unusual rhythm creates a unique pattern of day and night cycles, with one Mercurian day lasting about 176 Earth days. These cycles contribute to the extreme temperature variations on the surface, from a scorching 430 degrees Celsius during the day to minus 180 degrees Celsius at night. Despite its slow rotation and lack of a thick atmosphere, Mercury still maintains tectonic activity. Long, cliff-like features known as lobate scarps stretch for hundreds of kilometers across its surface. These scarps likely formed as the planet's interior cooled and contracted, causing the crust to buckle. Some of these structures appear geologically young, suggesting that Mercury may still be slowly shrinking today. Looking ahead, scientists eagerly await data from the European-Japanese BepiColombo mission, which is currently en route to Mercury and expected to arrive in orbit by 2025. This mission is equipped with more advanced instruments than its predecessor, MESSENGER, and is expected to shed new light on Mercury's magnetic field, surface composition, and geologic history. The combined efforts of past and future missions promise to unravel even more of Mercury's secrets. Each revelation contributes not only to our understanding of this enigmatic planet but also helps refine our knowledge of how terrestrial planets form and evolve throughout the universe. Mercury, once considered a barren and inactive rock orbiting too close to the Sun, has emerged as one of the most scientifically rich and mystifying worlds in our solar system. As we continue to probe its surface and study its secrets, one thing becomes increasingly clear: the smallest planet holds some of the biggest mysteries.